Okay, let's look at this ridiculousness one last time in the heliocentric model and show unequivocally that this is 100% impossible in their model. Let's take a look at what they show us all the time, and then we're going to take a look at what can be mathematically proven to make this impossible. So when we look at the lunar eclipse, and all you have to do is Google it, and you're going to see, say, a lunar eclipse diagram. And what you'll end up with is different diagrams, but they pretty much look like this. And the fallacy of this happens to be that they are showing a sun which is huge, but not to scale. I'd say they're showing it about 2.5 times the size of the Earth here. And they're showing it extremely close. In fact, the moon is just barely closer than the sun. In any case, let's look at the fallacy of this and dismiss this for the last time. If the flat Earth community were to come out with a diagram like this to show something with the flat Earth, there would literally be dozens of comments below stating you're not showing it to scale. It's a trick you're using because if you do it to scale, you'll see it turns out right. And there would be videos by the professor and Marianne and Simon Dan and others who will never try things themselves to see if they're actually right or wrong. But let's get into it and take a look. And look at this. That's what I want you to notice first. And wait till you see the angles that they use. They use the satanic angles even in their stupid diagrams. So they're showing what I have here as the yellow lines, and that is the sun rays coming from the top of the sun. Why this is wavy and the others are straight, I have no idea. And by the way, if you search science, you'll find out that the photons, whether you think they travel in a wave or not, they will travel in a straight line in space. They don't disperse because there's nothing to disperse. There's no medium. So whatever angle they come out of the sun, they just go forever until they're interrupted, or until at some distance there is no more energy left. Now, we have the moon during a lunar eclipse is its normal grayish white self. When it gets into the penumbra, which is this grayer area here, is when it actually either turns black or very close to black. And when the moon gets right to about there, that line, that's when you first start to see a little teeny sliver start to turn darker on the moon. And it usually is pretty dark, close to black. And as the moon moves into this, and by the way, in their model, this is pretty accurate. Because by the time the moon moves around, they have to have all these angles. And the umbra has to be this thick for it to work, because this is a process that takes quite a bit of time, relatively speaking. Most lunar eclipses are about 6 hours or so in totality, start to finish. Now, so to produce the umbra, which is this right here, is these wavy lines hitting the outside of the Earth. And of course, they go down then, and it causes a red moon. We're not going to get into the stupid reason why they say it's red, but it's a stupid reason. And then, but what causes this penumbra? Well, the penumbra is caused, we got the first two lines right. The penumbra is caused by these other lines, which here you're going to see is somewhere between 20 and 25 degrees. And we're going to look at the angle of these two. You're not going to believe it. So this is the way that goes. From the top of the sun, it crisscrosses in front of the Earth, and that causes this penumbra. The others, which don't crisscross, but they happen to strike at the Earth at this angle, cause this umbra, and then it comes out in the penumbra on the other side. Now, I'm going to, let me see if I can do this, just a moment. Now what I've done is I have expanded the screen to the right so you can see the angles as I click on these lines right here. Now these lines, what they are, let me find something here so I can show you. I started out from parallel. So I took a line and I dropped it on like this, top of the sun. and I just moved it out parallel. And I did the same thing at the bottom. So that's about parallel there. And then I applied over here what degree angle. And you ready for this? Watch. I'm going to apply this to it. Minus 6.6 degrees. Watch what happens to that top line. Oh, it matches. And this bottom line right here is also, as you can see over here, minus 6.6 degrees, 66. Even in their satanic, well, we know it's satanic now, even in their diagrams, they have to use the satanic numbers. And it's not done here. Wait till we get to these right here. That's interesting also. And again, I did the same thing with these bluish type of lines here, these aqua colored lines. I started them out parallel at the top of the sun, parallel at the bottom of the sun, and now I just applied an angle over here. So let's see what angle got me to match their diagram. Let's click on this one here. 23.4 degrees. Does that sound familiar? Take 90 and subtract 23.4, because 90 is parallel. You get 66.6. And the top one, of course, it matches, minus 23.4, 66.6 degrees. How about that? Isn't that interesting? Now, one other thing I want to point out before we move on here, and I'll put a box here just so you can see it more easily. If angle A, which is where they crisscross, must equal angle C when it comes out the other side. So it's 23.5 degrees going in and 23.5 degrees going out. I hope that makes sense. So here's graph paper. And what I did was I did everything to scale the way they say it is. And every one little block on here is equal to 1 million miles. So let's zoom in and see what I did with the starting point. I have the front of the sun just touching this line right here. So that's the 0 mile mark. And then each box represents 5 million miles. So you have 0, 5 million, 10 million, 15. It's not, I didn't do every 5. You can figure it out. 20 million. All the way out until we get to 93 million. And by the way, to scale, you wouldn't even see this little line right here at all. Where the thickened line is, because I just wanted to point out where 93 million miles was located, and where this line crosses represents where the Earth is. If you put the actual diameter of the Earth on here, I would have to magnify this probably 5 or 6 more times before we'd even see a little speck. So keep that in mind. And because the line is so thin, it's actually positioned in the middle, but when I made it thin enough, as thin as I can make it and still show, it shrunk it down from the top down. So it's just a little off of dead center from where the sun is located, dead center. Now keep in mind also that a quarter of a million miles is where the moon is. So it would be only 1/4 of the box back from where the Earth intersects this line. So very, 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 very close in this scale. So let's back this out. Now let's look at the ridiculousness of all of this. So I started with one line, this purple line here. You can see it starts at the center of the sun and it proceeds to go to the center of the Earth right there. And like I said, this line, the violet line here, the purple line, it's thicker. So imagine if the Earth line was thicker, it would be dead on, you know what, accurate. Now let's take a look. Let me click on this line, and over to the right you can see there's the angle, 0 degrees, which means this is how many degrees off of parallel. Now if you do a Google search, 9 out of 10 results, if you say what angle do sunlight rays strike the Earth, they will say 90 degrees. If you get one that's very detailed, they will give you even more. And if you do the mathematics and you find a site that actually gives you the mathematics, it's about 0.14 degrees off of parallel. So 89.86 degrees is what the sunlight strikes the Earth at from that distance. And you can use the Pythagorean theorem to figure that out yourself. You know, the one part of the triangle is 93 million miles away. And then you can figure the height of the sun, which is 800. Oh, yeah, let me show you the sun. It takes up 80% of the box, as close as I could get it to 80% of the box, because it's 800 some thousand miles in diameter. So this is actually to scale. Now let's see how ridiculous their model is. Now I'm going to apply 1 degree. 1 degree off of parallel. And you see it stayed on the sun. It started, because I started the line from the sun, it'll apply that angle. And, oops. Now remember, they need 23.5 degrees in one of them, and 6.6 degrees in the other to make it work. And you're going to see this, how ridiculous this is when we take two lines, one from the top part of the sun and one from the bottom part of the sun, or east-west part of the sun, whatever way you want to look at this, one extreme to the other. And we're going to see where they crisscross. So let's apply 6.6 degrees to this. Doesn't exactly strike the earth, does it? Never will. It will. This light will never strike the earth. Neither would 1 degree off parallel. So let's go back to 0. And we're back on the earth again. They need parallel rays, but parallel rays do not produce Umbra Penumbra that we see that produces the lunar eclipse. Now I have two parallel lines, one from the top of the sun, one from the bottom of the sun, or left and right, whatever way, again, you want to look at it. And we're going to run those over parallel. And even parallel, they miss the earth. The outside part does. And so those who just loved making fun of me for saying, especially since it's a ball, and up here it would be tilted away from the earth. When the photons come out, they wouldn't be facing earth. I said that we would never see the outside part of the disk of the sun, because the rays would, if you do the math and if you do it to scale, they would not hit the earth. Not from the outside. They would from the middle, probably 2/3 of the sun, but not from the outside. But let's just say these are striking the earth. So the only way we see a full disk is with a local sun, much closer than 93 million miles. Now what we're going to do is we're going to apply these angles. Why don't we go with what they gave us in the diagram? And if you think it's just a coincidence, Rich, that the angles were 6.6 and minus 23.4, which gives you 66.6 degrees from parallel, then I don't know what to say. Anyway, let's go with, what am I on? I'm on the bottom line. So I think minus is what I need here. Minus 23.4 degrees. I got to go with a positive, sorry. 23.4. Ooh, can't wait till we apply it to the red line. Now, minus 23.4 here. Oh, where do they crisscross? So that the moon can, the moon would be way, way up here when it first entered the Umbra. If it was even striking, see, these have to crisscross in front of the Earth for it to cast a shadow on the moon. So let's just take a guess. 5, 10, 15, 20, 25, 30. I don't know if you can see the line. About 30 million miles away, which is impossible because the moon is only 250,000 miles away from us, is when the penumbra would start. And I don't know, we should have maybe a 3-day eclipse, whatever. But let's see where they cross. Remember, the angle had to be the same before and after the cross, and they are here, before and after. But it never strikes the earth. It can't produce a shadow for the moon, which is located just to the right side of this thickened line right here. It can never do it. Never. So let's just pick 1 degree off. Oh, let's just have a half a degree. Minus 0.5. Because I've had people argue, Rich, even just half a degree is enough. Really? Let's find out. So we have minus 0.5. And this will be positive 0.5. First, let's see where they crisscross. They start to crisscross at about 25 million miles away. And you can see it's a very shallow angle, right? And about 55 million miles away, they start to diverge again. Same angle in as same angle out. And guess what? They don't strike the Earth. They don't strike the Earth. Now what I did here was I put a moon on which is almost as big as the sun. But at this scale, I just have to do it exaggerated. And by the way, the bigger I make the Earth and the moon, the better it is for their model. The bigger it is, the easier it is for these rays from the sun to strike the Earth. Imagine if the Earth was the size of this whole thickened line here. Yeah, there'd be a shadow cast, a penumbra. But no, the Earth is as thin as this thinnest little line on here, even less. But I put these two lines on here because this is the kind of thing you'd have to have, except it would have to be right in front of the Earth, like that, where they would crisscross, which would put the sun out here somewhere. But it wouldn't even be that far out because you can't even go to that scale here. So I just wanted to make that point right there. There's no way this works. It doesn't work. Now let's bring it back down again. They crisscross way out here. Can't produce an Umbra Penumbra. Just can't do it. Mathematically it doesn't work. Physically it doesn't work. To scale it doesn't work. It just doesn't work, period. This is half a degree. Half a degree. Minus 6.6. That was their angle to get the Umbra part, right? So let's look at that one because I don't think we looked at this one directly. Maybe we did. 6.6. Are you kidding me? Yeah, so that crisscross is right. Yeah, that'll work for the Umbra if the moon was entering the Earth. Entering the shadow. See, the Earth. Here's the deal. The Earth would have to be right in here for the shadow to come out like this. The shadow would have to be in here. The Earth would have to be right in here, and the moon right behind it. Then, yes, you could have the moon come in and go down. Folks, we're not even close to that. And if you want to let's use the, because this won't cause it either. This is even, in a way, worse. 0.15. I think that's close enough. 0.15. If you do the math, that's about the most any sun ray can be off from from the sun and still hit the Earth. And as you can see, they don't crisscross at all. That's good. The crisscross is going to happen way, way, way down the line somewhere. No crisscrossing of any of them. So you can't get an Umbra Penumbra. You can't get it if it doesn't crisscross. And at 93 million miles away, and somebody's going to say, no, it changed it to 0.2. No, okay, that would be in your favor. But if I use 0.2, you'll see, what it does is it just rounds on the screen. You have to point these things out because moronic commenters will think that's wrong. So impossible. Cannot happen in their model. Absolutely impossible. There's no crisscross at 93 million miles away at all. No crisscross equals no Umbra Penumbra. The other side has proven that there is an Umbra Penumbra that takes place from our sun. Remember that? Which means you have to have a crisscross. So you bring in people who think this is wrong. All you have to do is do it to scale and show me how you get a crisscross from 93 million miles away to produce this thing right here. Not going to happen. Impossible. It's actually physically impossible. Take care.